So here we are at Kaggle's Intermediate Machine Learning exercise for XGBoost. All right. So in this exercise, we're going to use our new knowledge to train a model with gradient boosting. Here's the setup. Let's do it. Just press play here. Everything's pretty much normal there. We're also going to be training on the Kaggle Learn Housing Prices Competition data set. We're going to run this thing as usual as well. This is all standard stuff. Train, test, split. We're going to read the data, remove the rows with the missing targets and separate it from the predictors. Break off the validation set from the training data with train, test, split. We're also going to be having the low cardinality columns on here, and we're going to be having the numeric columns. We're going to be keeping the selected columns only with this stuff that we've done before. We are doing something new. We're doing one-hot encoding with this get dummies thing. Okay, so pd.getDummies, pardon me. I saw it in Gemini. Basically, this is just going to do one-hot encoding for us, so we don't have to like import the one-hot and do the whole thing that I already forgot how to do. All we have to do is this. So turns out, and then we've got this align thing because they might be misaligned after we do these get dummies on them. So when we do these align, it aligns them up to where they what's the word? Line up. I mean, where there's actually as many what are those things called? I forgot. There's as many features in the validation as there is in the test, basically. That's all it's saying. All right, so here we go. Step 1. Build the model. Part A. In this step, we're going to build and train our first model with gradient boosting. We're going to begin by setting my model 1 to an XGBoost model using the XGBoost.Regressor class. And then we're going to set the random seed to 0, so random state equals 0, and we'll leave all other parameters as default for now. Then we're going to fit the model to the training data in XTrain and X and YTrain, pardon me. So we've done this a lot. Okay, we did a lot with the random forest regressor. So, I mean, we could come over here. In fact, let's do it. Let's open this thing up anyway. Let's link to the stuff just in case you need to check it out. But like we've done this so many times that we pretty much should have it down by now. So let's say the my model 1 equals the XGBRegressor class, and then let's throw random state equals 0 inside of there as well. And then fit the model, so we'll get the model, my model 1, drop it there, dot fit. And just in case we forgot, we've got the XTrain and YTrain, so we know we're going to put these in there as well. So we'll do XTrain at the beginning, comma, and then we'll throw YTrain in there as well. I would double click this, but it turns into that other format if you double click. So there we go. So anyway, let's check it out, see if it's any good, and it's correct. There we go. Let's check the solution, make sure we don't have anything they don't have anything crazy there that we could have learned from. And no, it's pretty much exactly the same. All right. So we've got part B. We're going to set predictions 1 to the model's predictions for the validation data. We'll recall that the validation features are stored in XValid. So there's that thing like we had up there to show us fit this and that. And so we'll do that here. So we got predictions 1 equals, let's grab my model 1 right here, drop it off right here, dot fit. And then we will say XValid as well, Let's grab this, drop this here. That should be it, right? Yeah. Now we're doing predictions. Predict. What am I thinking? Remember, we're importing mean absolute error, and that's where the predict comes from. So let's do that. Or does it come from sklearn.metrics? And we're also importing. I don't remember. Anyway, so it's correct. Let's come over here, drop this down, look and see if it's anything different. No, it's exactly the same. Awesome. So we got part C over here. So finally, we're going to use the mean absolute error function. Remember, this is a function. This is in a class to calculate the mean absolute error corresponding to the predictions for the validation set. We'll recall that the labels for the validation data are stored in XValid. Gotcha. All right, so calculate the may. We're going to get this mean absolute error function right here. Open it up, toss it here, and then let's put YValid in there, right? I think it was something comma YValid though. I think it's like, let's put comma YValid and let's put the predictions. Do we put predictions 1 in there? I don't remember. Let's just see. If not, we'll go look at the text. All right, let's check it out. Oh, there we go. Awesome. All right, so let's get rid of this thing and check out the solution. Make sure it's right. Exactly the same. Oh, no. We need to get rid of this so we can print it out. See what our May looks like. And it's 18161. Not the best, not the worst. We'll deal with that in a little bit. All right. So we got step 2, improve the model. So now that we've trained a default model as baseline, it's time to tinker with the parameters to see if we can get a better performance. Okay. So we'll begin by setting my model 2, to an XGBoost model using the XGBoost regressor class, just like we did. We'll use what we learned in the previous tutorial okay. We'll use what we learned in the previous tutorial to figure out how to change the default parameters like in estimators and learning rate to get better results. Then we're going to fit the model to the training data, X-train and Y-train. Then we'll set predictions 2 to the model's predictions for the validation data. We'll recall that the validation features are stored in XVal like we did up there. And then finally, we'll use the mean absolute error function to calculate the mean absolute error corresponding to the predictions. I mean, this is just cut and paste. And we'll recall that it's stored in YVal just like up there. In order for this step to be marked correct, our model in my model 2 must attain a lower May than the model in model 1. Gotcha. Okay. So, first things first, let's get the XGBRegressor class. Let's just grab this right here while we're at it. Toss it like thus. Let's give it a couple of parentheses and let's toss some stuff in there. All right, so let's do an in estimators first. Remember in the the text, we did it to up to 1,000. So let's say equals 1,000. Why not? Comma. What else does it say? Learning rate. Okay, so we got learning rate. Oops. All right, and that's going to equal, and remember we did it to 0.05 on that one, so we've got that there. And then we're going to fit the model. All right, so remember the fitting the model was different, and I don't remember exactly how to do it. So let's come and look at this thing right here. So let's go all the way to the bottom one because the bottom one was the best one, and let's check that one out. All right, so here we go, the myModel.fit. Let's just grab all this right to there, and let's come over here and let's just drop it here, do myModel2. Let's drop this and put a period in between it. All right, so now we've got this going on. Remember I was saying in the last video that this needs to be up here. So let's just leave the early stopping rounds down here to see specifically what happens when we do that. Looks good. Predictions 2, let's throw the predictions in there. Let's go find the predictions up here and toss it in. Let's do this. Grab that, drop it down here, change it up to my model 2. Let's grab the May while we're at it. All right, the May is right here. All right. Let's drop it down here. Where are we? Not here. Here. Let's drop that right there, and then let's try what? Mean absolute error. That looks good. Okay, let's change predictions 1 to predictions 2 right here. And that should be good for now. Let's check it out. It's correct. We got a mean absolute error of this, but as we can see, user warning, early stopping rounds and fit method is deprecated for better compatibility with scikit-learn. We should use it in the constructor or the set params instead. All right, so let's grab this with a Control X. Let's drop it off right here after we put a comma in. And let's bring it back up to here just so it looks professional. All right, and let's get rid of this too while we're at it. All right, so there we go. Let's run this. Let's look at this. All right, so we got a May of 170.32, and that is correct. All right, but the thing is, I'm pretty sure we went down to under 17,000. Okay, I'm pretty sure we went under 17,000. So you know what? I did this in rehearsal too. So you know what we're gonna do? We're gonna take this stuff. Okay, so let's just grab this right here. And let's go get our buddy Gemini. All right. Let's say help us tune the hyperparameters for this XGBoost model. Semicolon, we're learning on Kaggle Learn. All right, let's see. Blah, 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 blah. In estimators, we don't need to mess with that. Learning rate, we don't need to mess with that. Early stopping rounds, there we go. Okay, so max depth. Max depth, give us some examples of what max depth should be. Give us some examples of what the tuning should be on max underscore depth, etc. All right, let's go. Blah 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 blah. Okay, here we go. So initial range for max depth 3 to 10. All right, so let's grab max depth while we're here. What in the world? Whatever. Anyway, max depth. Let's come over here. And this is going to take a lot of our time on this particular video right here, but whatever, right? This is what we're going to be doing in reality. So it said from 3 to 10. So let's go max depth equals 3. Let's check it out. 170.55. What was it before? What? Okay, so it wasn't even better. All right. 3's no good. Let's go to 10. What was the other one? 10? Let's go to 10. Run it. Come on. Definitely not better. Let's go to 7. All right. Is that better? No, that's not better. It was at 170 something. All right. So I don't think max depth is going to be good for us right here. So let's get rid of that one and let's find another one. All right. So max depth is no good. Let's try min child weight. All right. Let's see about this. Min child weight equals, let's see what they say. 1 to 10. What did it say? The higher the data set is very large. Okay, so let's start off with 10. Why not? Run it. No. Okay, so that's no good. Let's go with 1 then. No, that's the exact same. Let's go to 5. No. Okay, so max child weight is crap also. Or min child weight, whatever. That was no good also. Let's try to find another one. Subsample, alright? 0.6 to 0.1. Let's see. Let's say subsample equals, let's go to 0.6. It wasn't 0.1, it was 1, right? Yeah. Ooh, look at that. So that is a lot lower. That's 400 lower than we were at. Awesome. Let's toss 1 on there. See what we get. Nope. Okay, so 1 is going to be where we started at. So let's go to 0.7. Maybe it's a parabola. What was the other one? 166. Ooh, that's better, huh? Let's go 0.8. 16,373. Oh, 160.51. I think subsample is going to be, we're going to keep this one, all right? So let's keep that one because that definitely dropped it down nice and low. Let's go see what else we got. All right, call sample by tree. And it's going to be 0.6 to 1 as well, all right? So let's toss call sample by tree equals, and let's go 0.6. I said 0.6. All right, let's do it. Ooh, 15,000. That's good. Let's go to 8. Why don't we go to 8? Just skip all the BS. Okay, 16,541 was the last one. 541. This one is 8. Okay, 541 is better. Let's just go to 7 and see what we get. Let's see if 7's in good. 541's there. Okay. Okay. So there, let's keep that one. 164. Wait, no. What was the other one? Were we in the 15s yet? No, we were in the 16s. Okay, let's keep it on 7 right there. All right, and this is basically this. I'm pretty sure this is basically how it's done. We just keep tuning parameters until we get better stuff. All right, so we got gamma, gamma, gamma. Let's see what gamma gives us. This is going to be 0 to 0.5. So let's start with 0.3 while we're at it. Why not? Let's come over here. Let's drop a comma. Gamma equals, and then let's say 0.5. How about that? What were the numbers? 0.5. Oh, whatever. We'll just start. Okay. Nah, that's no good. Let's try 0.3. Same. Let's try 0.1. Same. Okay, so gamma doesn't do anything. Let's get rid of gamma. Okay. 463. 460. Okay, gamma doesn't do anything, right? So let's not worry about gamma. Let's go do another one. All right. Reg alpha, reg lambda. All right, so these are two different ones. And the initial range is 0 to 1 or even 10 or 100 for reg alpha in some cases. And then for reg lambda, it starts with 0 or 1. And overfitting is a significant problem, so we'll go down. So reg alpha, we'll do it kind of like this. What? Randomized search CV. I don't want to go through all that. So let's just start with reg alpha and reg lambda because I think these are a pair. So let's go reg alpha equals comma, and let's just do this. We can say lambda. We just type in lambda equals. All right. So reg alpha, let's start with 0.1, and for reg lambda, let's go 0.9. All right. Let's do it to where we go up on this one and down on this one. How about that? Let's check it. Is that better? That looks better. Wasn't it 400 something? Okay. Let's go up. Let's go to the 10. Let's keep this one here and let's go 10 on this one. How about that? Okay, we got 039. 16039. No, not good. All right, let's go to 5. Oh, 15,000. All right, so we're in the ballpark. Let's go 5 on this one. Why not? No, 5 no good. 5 no good. Let's go 0.2. 588 still the same. 1588 still the same. Let's try a 7 on this. I'm about to just say 15,000 is pretty dang good, so we might as well keep it. Let's go 4 on this. If it doesn't, if it goes up again from the 15,000, okay, let's just keep it on 7 or 5. I mean, run it. Let's send this back to 1. All right, good enough. All right. So basically, and you know, there's a ton more hyperparameters we could mess with, but there we go. We're really low compared to where we started right now. I mean, we've never touched 15,000 before, so that's pretty good. Let's just keep it at that. Pardon me. Let's look at their solution, and you can see they didn't do anything like what we did, but it's okay because, you know, it's cool. We got a better score. All right. So here's step 3. We're going to break the model. So in this step, we're going to create a model that performs worse than the original model in step 1. And this is going to help us develop our intuition for how to set parameters. We might even find that we accidentally get better performance, okay? Which is ultimately a nice problem to have and a valuable learning experience. Okay. So it's the same stuff that it said before. In order for this step to be marked correct, our model in my model 3 must attain a higher may than the model in my model 1, right? So we're trying to beat this 18,161. We're trying to make it worse than this. So any number higher than that. All right. So let's start off by grabbing this stuff right here. All right. Because that's what we're going to have to do. We're going to have to do exactly what we've been doing. And let's drop it right here, and then let's change everything up to 3. All right. So let's call this 3. 3. Let's take this, drop it here, drop it here. Let's take this and turn it to 3. Take this and turn it to 3. Grab this, put it in here. All right. Let's run it just to make sure it works first. Let's get rid of this thing here. Run it to make sure it works. All right. So it still works. So now let's break it. All right. So first things first, let's get rid of all of this. First things first. Let's get rid of all that. Now let's run it. Take your time. Oh, because it's 1,000. Oh no, it worked. Okay, so that's good because it went to 1,000 and we didn't say stop when it gets to the lowest one. It just kept going and it gave us this one that's just a little bit higher than the other one. So there we go. We don't need to go any further. That's good. Let's get rid of this and see what they did. And they did in estimators 1. Okay, we could have done that, but we didn't. Whatever, doesn't matter. All right, so there we go. So now we're going to keep going. We're going to continue to learn about data leakage. This is an important issue for a data scientist to understand, okay? And it has the potential to ruin our models in subtle and dangerous ways. Sounds important. All right, so let's go over to data leakage right now. All right. So now we're on to data leakage, and we'll see you next time.